Hello, I'm Philip Mann, Technical Director at Kappler. Today's topic is penetration versus permeation. Which test method is best for my chemical hazard application? But first, let's take a look back. Prior to the development of ASTM test methods for penetration and permeation, most companies would use contact degradation as their method for determining a material's resistance to a chemical. They would place the chemical in contact with the material for a period of time and then conduct visual observations to determine cracking, swelling, color changes, or other physical changes. In the mid-1980s, people began to understand the phenomenon of chemical permeation. And what they discovered is that chemicals can permeate materials with no visible evidence or any changes that would occur. A liquid chemical can present a liquid challenge or a vapor challenge. When measuring permeation, you're always measuring a vapor. When measuring penetration, you're always measuring a liquid. So it would seem simple then that if I have a liquid, I conduct a penetration test. If I have a vapor, I conduct a permeation test. But it's just not quite that simple, because there are these liquid chemicals that also like to become vapors. We call them vapor-producing liquids, or liquids that produce vapors. The NFPA 1992 standard provides specific criteria for when liquids should be considered vapor hazards. The NFPA standard uses a vapor pressure value of 5 millimeters of mercury at standard conditions. If the vapor pressure is higher, the chemicals should be considered a vapor hazard. Now, there are also some industry experts and other information available that would indicate a value of 40 millimeters of mercury should be the threshold for when a liquid chemical should also be considered a vapor hazard. Another issue that impacts the decision is that there are many vapors that skin notation information is not available. So we don't know at what concentration that vapor truly becomes a hazard to the skin. So from a protection standpoint and a safety standpoint, we really have to consider any level of vapor a hazard and any potential for vapor a hazard. One other misconception that we need to clear up is the belief that if you conduct a permeation test with acceptable results, that you would also pass a penetration test. And this is not necessarily true. You could have a liquid chemical with a very low vapor pressure and also a very low surface tension that would represent a low permeation hazard, but a high penetration hazard. So to review, to determine when you should conduct a penetration test or a permeation test, you should determine the vapor pressure for that chemical. This information can be obtained from the safety data sheet. Today's topic has been penetration versus permeation.